Hello and welcome back. In this tutorial we are going to talk about components of a vector. Let us begin our discussion by placing a vector A on this Cartesian coordinate system, namely the xy system. We subdivide the scale so that this point be 5 and this point be 8 as an example in our discussion. And this tip of the vector is 8, 5. And therefore, we write ax as 8, that is called the x component of our given vector, and the ay is equal to 5. And the magnitude of the vector is ax squared plus ay squared, in this case, which is 8 squared plus 5 squared taken from the square root. If you want to determine the angle is tangent of theta is equal to ay divided by ax, where this is actually the angle theta. The angle theta is the angle between the positive x-axis and the given vector A. Theta is therefore the tangent inverse of ay divided by ax. Let us substantiate what we have talked about with an example. Example 1, find the components of the following vector. If this is a vector, force vector, F is equal to 200 newtons, then we are required to calculate Fy and Fx, which are called the components of the vector, and the angle is theta is equal to 37 degrees. The solution is, first of all, we need to remember that cosine of theta is the adjacent side divided by hypotenuse for such right-angled triangles, which is Fx divided by F. So Fx is simply F cosine of theta. So Fx is 200 times cosine of 37, which is 160 newtons. Similarly, since sine of theta is opposite divided by hypotenuse, which is Fy divided by F, therefore Fy is simply F sine of theta, which is 120 newtons. Let us see some trigonometric relations so that our discussions will be at ease. Cosine of theta is adjacent divided by hypotenuse, which is, according to this right angle triangle, is ax divided by a. Sine of theta is opposite over hypotenuse, which is ay over a. Tangent of theta is opposite over adjacent, which is ay divided by ax. There are these inverse trigonometric relations. Secant of theta is 1 over cosine of theta. Cosecant of theta is 1 over sine of theta. Cotangent of theta is 1 divided by tangent of the angle theta. And you have to remember this trigonometric relationship so that it will be easier for you to find the components of a vector and everything associated with it. The IJK unit vectors. Let us see the standard unit vectors, which are also called the IJK unit vectors. And this is the Cartesian coordinate system in 3D. And this unit vector along the z direction is called the k unit vector. And the unit vector along the y direction is called the j unit vector. And the unit vector along the x-axis is called the I unit vector. And these are called the standard unit vectors. And every unit vector has a magnitude of 1. And these standard unit vectors are called standard because they are associated to the directions of x, y, and z respectively. And we usually place a hat over them, I hat, k hat, j hat, as you can see. If vector A has the components, ax is equal to 8, ay is equal to 5, and az is equal to 4, as an example, then we write our vector A as 8i plus 5j plus 4k. The unit vectors I, j, k are unit vectors whose magnitudes are 1 and the directions of x, y, and z are the directions respectively. The magnitude of a vector. The magnitude of a given vector A is given by, for example, if the vector itself is ax in I plus ay in j plus az in k, where ax, ay, and az are the components of the given vector, then its magnitude is simply the sum of the square of each component squared taken under the square root. So if, for example, our vector is 8i plus 5j plus 4k as an example, then the magnitude of this vector is simply 8 squared plus 5 squared plus 4 squared under the square root, which is simply 10.2. Unit vector of any given vector. The standard unit vectors have a magnitude of 1, and they are always in the direction of, the ijk's are in the directions of x, y, z respectively. But what if we are given a certain arbitrary vector, vector A, and then if we are asked to find the unit vector associated with it? The answer is the unit vector of any given A is designated or symbolized by u subscript A with a hat over it. That is the unit vector of the given vector A. And if our vector is ax in I plus ay in j plus az in k, then the unit vector of the given vector A is simply A, the given vector itself, divided by its own magnitude. And we can designate that on the Cartesian coordinate system, xy system, as, for example, if this is our vector A, then this is the unit vector of the given vector A. This is the unit vector of A. So the unit vector of A has a magnitude of 1, and it is in the direction of the given vector itself. Example, find the unit vector of a vector A is equal to 3i plus 4j. Clearly, the unit vector is simply the given vector divided by its own magnitude, which is simply very straightforward, 3i plus 4j divided by the square root of the sum of the square of the components, which in this case will give us 3/5 of I plus 4/5 of j upon very simple mathematical simplifications. The second example is find the unit vector of a vector A is equal to 2i plus 8j minus 9k. The unit vector of A is the given vector A divided by its magnitude, which is simply 2i plus 8j minus 9k divided by square root of 2 squared plus 8 squared plus 9 squared. We simply make the square of the denominator and take under the square root. We get simply 2i plus 8j minus 9k divided by square root of 149. The third example is find the unit vector of a vector A, which is 6i plus 8j plus 10k. Again, very clearly and in a straightforward way, the unit vector of the given vector is the vector A given divided by its own magnitude, which is 6i plus 8j plus 10k divided by the square root of 6 squared plus 8 squared plus 10 squared, which will give us 6i plus 8j plus 10k divided by square root of 200. With a little simplification, it can also be reduced to 3 over 5 root 2i plus 4 over 5 root 2j plus 1 over root 2k. Sometimes if it can be simplified further, we have to simplify it, but otherwise this is the direct procedure that we have to go along in order to find the solution of finding the unit vector of any given vector. Note that a unit vector has a magnitude of 1. So, for example, if you wanted to verify that this unit vector that we have calculated a while ago has a unit or has a magnitude of 1, the way we can verify that is simply we can find the magnitude of the given unit vector, then 3 over 5 root to the whole squared plus 4 over 5 root to the whole squared plus 1 over root to the whole squared. Then upon some algebraic simplifications, it turns out that the magnitude of this unit vector is 1, and the answer is not surprising because every unit vector has to have a magnitude of 1, and it turns out to be the same. Let us recap what we have seen in this short tutorial. On this Cartesian coordinate system, we can represent a vector A, and that vector A is at an angle of theta. If this part is the x component of the vector, that is ax, and this height is the y component, that is the same as coordinate read from this part, then ax, that is the x component of the given vector, is simply a cosine of theta, and ay is a sine of theta. Theta is tangent inverse of ay divided by ax. If our given vector is A is equal to ax in I plus ay in j plus az in k, that is on a 3D Cartesian coordinate system, its magnitude is simply ax squared plus ay squared plus az squared. This is called the magnitude of the given vector. And its unit vector is simply the given vector A as it is divided by its own magnitude. That is called the unit vector of the given vector.